Alrighty, folks, let's take a look at your DMR. Today's your last day to ask questions before your quiz releases to you at 12:15 today. Excuse me. Mr. Mejia's class is 3/8 virtual and 5/8 in person. Which makes up more of Mr. Mejia's class, virtual or in-person students? So we have 3/8 and we have 5/8. These fractions have the same denominator. When fractions have the same denominator, we look at the numerator to see which is greater. And 5/8 is greater than 3/8. 5/8 was the virtual, or I apologize, was the in-person, so he has more in-person students. Okay, the question was which makes up more, virtual or in-person, not which fraction is greater. A lot of you got tricked last night. Okay, it asks which one makes up more of the class, not which fraction is greater. Let's take a look at our next one, comparison, using the less than, greater than, or equal to signs to compare. We can see that this is a 2-digit number. It has a tens and a ones. This is a 3-digit number. It has a hundreds, a tens, and a ones. Anytime we have a non-zero larger digit number, that is the greater number. 130 is greater than 89 because it has a hundreds place. So 89 is less than 130 should be how that looks. Questions, concerns, or comments on this one? We rocked that one pretty well. Leah.
On the first one, I didn't get it.
Alrighty. So our first one is here. What part do you not understand?
So I didn't get the which makes it up more in the class, virtual or in person students.
Okay, so do you see how 3/8 are virtual? Do you see how 5/8 are in person? Would you agree that 5/8 is a larger fraction than 3/8?
Okay, now I get it.
All right. Aiden Hampton.
Why does this look like the same DMR we had yesterday?
It is.
Oh,
Alrighty, moving on to slide 4, or question 4, I apologize. Look at the fraction below. I don't know why I'm yawning so much. I got more sleep last night than I have all week. Choose all that is true about this fraction. All in this case is 3. Okay. This fraction is 6/6. So this is a unit fraction is false. A unit fraction is 1 part. This is all 6 parts. There are 6 pieces in this whole. That is true. Our denominator tells us how many parts there are. This is more than 1/2. That is true. 6/6 is the whole thing. The whole thing is more than half. It takes 6 of these to make a whole. That is false. If we had 6, 6, 6 times, we would have 6 wholes. And this is equal to 1 whole is true. If we have all 6 of the 6 parts, we have everything there. Questions on that one? All right. Last two. Type the missing number that makes the equation true. We are 3. We got to get to 12. We can use our songs. 3, 6, 9, 12. It's a very funny looking 2. We counted 4 times. 1, 2, 3, 4. So 3 times 4 equals 12. Questions on that one? Alrighty. Next up, compute to find the answer. 668 subtract 259. 8 ones subtract 9 ones is impossible, so we've got to regroup this. So we are going to borrow a 10, and that is going to give us 18 ones. 18 subtract 9 is 9. 5 tens subtract 5 tens is 0 tens. 6 hundreds subtract 2 hundreds is 4 hundreds. So our answer is 409. That is the answer you should have found. Questions on that one? Attempted.
My question on this one, but can you go back up?
To what problem?
I think 4. Yeah, 4.
This one?
Yeah.
What about it?
Can you show me the answers back on? Yeah. Okay, thanks.
All right. Your DMR is going to unlock to you today at 12:15 for your quiz. Make sure that you are doing this one completed with your best effort, as it will be for a grade. Okay? Alrighty, 1 second. Okay, today we are going to take a look at line plots. Okay, line plots. Those are a type of graph that we have looked at before. We're going to look at them in detail. Before we just did an introduction. Now we're going to take a look at how to read them and use the data from them. Okay, so let's take a look at it. What is a line plot? Here is a brief video to teach us. What? Hush. Here we go.
Welcome to Kids Academy.
Hello boys and girls, this is Teacher Michael, and today I'd like to talk to you about line plots. Well, what is a line plot? A line plot is a quick and easy way to display and organize some information. Let's take a closer look at a line plot so that way we can easily identify or see what is a line plot and what's not a line plot. So in our example, we have some animals, and we also see the heights of each of the animals. Now, I'm guessing these are stuffed animals because the heights are kind of small. So I see one animal, the panda, is 33 centimeters, and other animals are 30, 29. I see another animal that's 30. So if we look at our line plot, and the line plot is this section of information right here with X's and numbers, we'll see all of the heights of the animals listed at the bottom. We'll also see some X's right above. Now those X's represent, each X represents one animal. So I know that by looking at this line plot, there is one animal that is 29 centimeters tall. And that is true because if you look at the animals, you can see that the mouse is 29 centimeters tall. If you look at the line plot, you'll also see that there are 3 animals that are 30 centimeters tall. Those animals are 1, 2, and 3. Those 3 animals are represented by these 3 X's. So I hope you can begin to see that a line plot is really just a nice, easy way to organize information. So based on this, can you tell me how many animals are 32 centimeters tall? Well, let's go over to 32 centimeters and see. Well, I see that there are 2 X's, so I know that there are 2 stuffed animals that are 32 centimeters tall. And if we go back and we look at our picture, we can see that the alligator is 32 centimeters tall, and so is the donkey. So this is what we use our line plot for. Let's read the directions for our worksheet, What is a Line Plot, and get started right away. Which pictures below show line plots? Check the correct answers. Okay, let's take a look at this first graph right here. So this first graph is really nice. It shows everyone's favorite animals. You can see mice, lizards, cats, and dogs. Although it's a really nice way to display information, it is not a line plot. Here's why. One reason it's not a line plot is it doesn't have the numbers on the bottom that our line plot had in the example. Also, this graph has colorful bars and not X's. So these are 2 reasons that this graph is not a line graph. This graph is actually called a bar graph, and it's another great way to organize information. But it is not a line plot. Let's take a look at our next picture. Our next picture shows the heights of plants, and already I'm beginning to think it is a line plot. First of all, I see the numbers on the bottom, just like in my example, so I think that is one reason it is a line plot. Another reason I think it's a line plot is I see the X's above some of the numbers. So this tells me that for heights of the plants, there are 3 plants that are at 2. There are also 2 plants that are at 3. This is the same kind of information that we got from our line plot in the example. So I think that this picture is a line plot. Let's go ahead and check it. Let's look at our next picture. Our next picture has the numbers on the bottom and has the title of the graph's size of TVs. So, using this graph, I can see that one TV is 26, another TV is 2 TVs are 27 because there are 2 dots. So does this look like a line plot? I think so. Even though it doesn't have the X's like our example and the other picture we saw, it does have dots to represent each TV. And whether it's a dot or an X, they're set up in the same way. They have the numbers on the bottom, and each dot or X represents just one TV. So this is a line plot. Let's go ahead and check it. Our final picture is really awesome also, but it is not a line plot. This is a picture graph. I know that because there are pictures. I can see the pictures of the apples, of the kiwis, and the bananas, and the strawberries. Another reason I know it's not a line plot is because there's no numbers on the bottom. We have the names of the fruits. So this is a classic picture graph. Remember, boys and girls, that when you're looking for a line plot, you can look for the numbers on the bottom and the X's or dots above the numbers that represent just one. Each X or dot just represents one TV or one animal. Thanks for watching, boys and girls, and we'll sure to see you next time.
Alrighty, so looking at what are line plots, let's go ahead and get to some practice today. On your seesaw, if you click on that activities bulb, it will refresh your feed. And you will see that there is an activity called Interpreting a Line Plot. Go ahead and click on that Add Response. All right, we're going to work on slides 1 through 6 together, and then you are going to work on reading and interpreting line plots on our remaining pages. Okay? All right. So this is how we're going to read and interpret line plots. You will notice there is a line plot here for us. Let's look at what we know already. We know that this is a title, and it tells us the number of scarves. We can see our category is an option of having 0 scarves, 1 scarf, 2 scarves, 3 scarves, and 4 scarves. A craft store asked some people how many scarves they owned. So now we know that this is the number of scarves that are owned. Okay? Let's take a look here. How many people have at least 1 scarf? Go ahead and underline at least 1 scarf. When we see the words at least, it means there could be greater amounts or more amounts, okay? We have at least, and that means it could be more than 1, okay? So we're going to start at the 1. And I see that there are 1, 2, 3 plots here. I'm going to put a 3 above there because I've got to count each line of X's that is at least 1, okay? These people own 2 scarves, and 2 scarves is at least 1. So we've got to count how many they have. 1, 2, 3, 4, 5, 6, 7, 8. 8 people have 2 scarves. Let's go ahead and write an 8 at the top of that line. Again, this is not asking how many people own only 1 scarf or exactly 1 scarf. It's how many people own at least 1 scarf. So it's 1 or more. On our 3, we have a stack of 4 X's. 1, 2, 3, 4. So let's put a 4 at the top. I like labeling how many I have in each category because then when it's time to add or subtract them, I don't have to recount my graph. I've got the information already. And finally, you guessed it, let's look at 4, because if I own 4 scarves, I have at least 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 10 scarves. So now the question is, how many people have at least 1? We've got to combine all of these. This is where some good mental math can come into play. All right? So over here, I know that I've got to add 10 plus 4 plus 8 plus 3. Because these people own 1, 2, 3, or 4 scarves, which means all of them have at least 1 scarf. Okay? I know that 8 and 3 is 11. If I add 4, that's going to give me 15. So I have 15 ones. That is represented as 1 10 and 5 ones. One 10 plus 1 10 is 2 10s. So this is equal to 25 people. 25 people have at least 1 scarf. Now I notice that there is a category right here that we did not count. We did not count this category. Who can tell me why we did not count this category right here? Why didn't we do that, Steve Rogers?
Because that's the zero. Because people in that category have 0 scarves.
Awesome. And if you have 0 scarves, you don't have at least 1, so you would not be included in the answer to this survey. What questions can I answer about this line plot that we've begun working on here? I'm going to lower hands because those are old. What questions can I answer about this line plot? Yes, Terrence.
So, there's another reason that we can't add that is because it's an adding. So if it was minusing, we still couldn't subtract 0 from itself.
So this is showing that one person owns 0 scarves. One person owns 0 scarves out of the survey that they took. All right, let's move on to slide 2. Some people drew cards that were numbered from 4 through 9. So our title of our graph is Drawing a Card Between 4 and 9. Our category down here shows us the cards that people drew. So when they picked a card out of the person's hand, 2 people drew a 4, 0 people drew a 5, and so on. Let's look at our question. How many people drew a number less than 8? Less than 8, we know this means smaller. So 7 is smaller than 8, 6 is less than 8, 5 is less than 8, and 4 is less than 8. So we're going to add up these items, okay? On slide 1, I showed you how to count and add because there were a lot of X's here. Look at slide 2. This has a little bit less X's because I already know what 2 plus 1 are. That's 3. So I'm just going to actually count these myself. So I'm going to invite you to do the same. Get a color that can show you've touched each X. And we're going to count these X's to find our answer. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 people drew a number less than 8. This time I didn't count up each category and then do an addition sentence because this is super easy for me to see. 1 plus 2 is 3, and then I just got to add those 7. And I know that that equals 10. Now, if this is difficult for me to see, you can absolutely use addition. You can use that strategy of writing how many there are and then adding them together. Okay, and then you would be able to find the amount. Questions on that? Alrighty, I'm going to take a look at your screens here. Looks like we're tracking. Josh, are you on that seesaw assignment, bud? It's looking like you're on Clever right now. That's confusing to me because we're working on this together. All right, let's take a look at slide 3 together. Slide 3 says, the art teacher wrote down how many flower pots each child painted last week. Notice the title of our graph matches, Painting Flower Pots. And at our bottom, we can see our categories. Okay, some children painted 0 flower pots. No children painted 1. Some painted 2. Most children painted 3 flower pots. The question is, how many children painted exactly 3 flower pots? So if we're working with an exact number, we only need that category. So I am only going to count the X's that are in category 3 because it says exactly 3. Okay, so let's take a look at this. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 children painted exactly 3 flower pots. All right. I want you to notice that there is a difference between the category and the number of X's. A lot of students think this means the answer is 3. This means that each X represents one person who painted 3 flower pots. Okay, so that means that there were 9 people who made 3. 1, 2, 3. So this right here is 1X. And then this one right here would be another person who made 3 flower pots. Okay, so we've got to be careful that we don't look at those numbers and think that that's our answer. Our answer comes from the data in the X's. That is where our data is shown. Okay, any questions on this one so far? Yes, Terrence.
The key and data and data.
So these actually don't have keys. So this is not, there's nothing here showing us that an X equals 3 people. So this is only by 1. So we are counting by ones. So our scale or our key here is understood as 1. Good vocabulary mention. All right, let's take a look at slide 4. Slide 4 says, Fred figured out the scores at the end of a card game. Use the data in the tally chart to complete the line plot below. Okay, so here we have the data. This is the number of people who scored that amount. Okay, so in a card game, 4 people scored 4 points. 2 people scored 5 points. 3 people scored 6 points. So again, don't look at these numbers and think it's telling you the answer. That is telling you the score, okay? And this many people did that. Justin, I think it's going to be really hard to focus on your math when you're throwing a ball up in the air facing sideways. You're probably not going to want to do that in the middle of a lesson. All right. So it says, click to select the X's. Our X's are down here. And we can't clear a column. So Mr. McKinney made a little mistake, and that's okay. So it says that we're going to figure out how to finish 4. So let's look at 4. People who scored 4 points, how many are there? Look at those tallies. Yep, 4 people. So we're going to duplicate this X to have 4 of them. 2, 3, 4. Go ahead and do the same thing. So we're completing this line plot by adding the 4s. So here's 1, 2. Go ahead and drag them onto the line plot to represent the 4 people who represented 4 points. One thing that a lot of my students notice every year is that if you were to imagine a bar around the line plot, it looks very similar to a bar graph. So for that reason, you don't want your X's to just be anywhere at all. You don't want your X to be all the way up here, because then to the reader that can look like, wait a minute. Do they have 4? Or are they all the way up there? Are they by what? So we stack them right up on top of each other to make a straight line, just like we would imagine a bar graph would have. Okay. So 4 people scored 4 points. We know that from our frequency tally chart here. Questions on that? All right, we're making good time, kiddos. Let's take a look at slide 5. Okay, this is how we find the data to create a line plot. So let's read and think carefully. Mrs. Mendoza measured the thickness of several pieces of foam board for an art project. She recorded the thickness of the boards in this line plot. So here's the line plot right there. In her line plot, it's using a dot instead of an X, but it's still in the same form. The thicknesses are down here. This many boards were 1/4 of an inch thick. This many boards were 1/2 of an inch thick. This many boards were 3/4 of an inch thick. And this many boards were 1 whole inch. Okay? So let's see which one is correct over here. I notice over here it says each dot represents 1 board. Which table matches the data in the line plot? Well, I guess I'm going to have to know what the data is. So let's see how many are 1/4 of an inch thick. 1, 2, 3, 4, 5, 6. Let's put a 6 up here above 1/4 of an inch thick. So I need to find an answer where in 1/4 it says 6. So let's look at A. Here's 1/4 and it says 5. That's wrong. A is gone because we have 6 boards that are 1/4 of an inch thick. Let's take a look at B. 1/4 has a 6. Okay, so B could be correct. Let's look at C. 1/4, 5. Nope, that's incorrect. Let's look at D. 1/4 and has 6 boards. So that's correct. Okay, so our answer is either going to be B or D. Let's keep doing some work here to find out. How many boards are 1/2 of an inch thick? Let's look. 1, 2, 3, 4. 4 of our foam boards are 1/2 of an inch thick. Let's go look at the 1/2 and see which one has a 4. 1/2. Oh, that one's already gone. 1/2, this has 4. Yep, that's good. Let's look at D. Oh, look, 1/2, they only said 3. That's wrong. So B is our only answer choice left so far. Let's make sure the rest of it is correct. I'm going to look at 3/4. There are 1, 2, 3 boards that were 3/4 of an inch thick. And look here, there's a 3. Yay. How many boards were 1 inch thick? 1, 2, 3, 4, 5. And yep, There's a 5 in the 1-inch category. So B is our correct answer. So what do we do here again? We counted the dots to see if they matched the number of boards. Okay, how many boards were that thick? That matches those dots there. All right. Questions, concerns, or comments on that one? All right, this next one is our last one that we're going to work on together. 6. So on slide 5, we saw a recorded data chart. On slide 4, we saw a tally chart. On slide 5, we have what is called a set, okay, a set of numbers. So let's take a look at what's asked of us. Some students were surveyed about how many pairs of sandals they own. Use the data to complete the line plot below. 0, 1, 3, 4, 5, and 6 are already done for us. They're dark purple. It's asking us to complete 2. Okay, so let's go count how many 2s there are. Look at our data set. Here's all the zeros. This many people own 0 pairs of sandals. This many people own 1. This many people own 2. Let's count the 2s. 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 people who own 2 pairs of sandals. So we need 9 X's. I have 1, duplicate to 2, 3, go ahead and get yours done. Have 9 X's. And then just like we did before, we're going to stack these up so that they represent how many people own 2 pairs of sandals on our bar graph or on our line plot. 4, 5, 6, 7, 8, 9. 9 X's to represent the 9 2s that we have. Okay. Just to review, you could check on the zeros. I see that I have 1, 2, 3, 4, 5, 6, 7, 8. And that is because over here, when I count, I have 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. I could do that for each one of these. If I were to count my ones, I have 1, 2, 3, 4, 5, 6, 7 ones. And then over here, sure enough, 7 people own 1 pair of sandals. So this is just the results of the survey. Okay. All right. For your independent work today, you are going to practice reading line plots. Okay, this is our first day with line plot reading and interpreting, so it's going to be a practice day. I'll give you some feedback on what you're understanding well and what you need to continue to work on. Slide 7 tells you to independently complete slides 8 through 15. On each of the slides, you will follow a problem that looks very similar to what we have done together. The only difference is it's a different graph and questions. But each of these problems were solved in the examples. So if you look at this and you say, I don't know what to do with those X's, then you can go back to where we did something with the X's and figure it out. If you look at this and say, I don't know what A, B, C, and D are, then you can go look at where we figured out what A, B, C, and D are. Okay, so we have one of each that we have worked through. On slide 15, there is a link to a line plot game. Okay, you're going to play a game to build some data, and then you will graph that data on a line plot. Okay, that game is to be played after you complete slides 8 through 14's work. That is your task for today.